Folks, I think we have some good critical mass, so I'm going to start us off. Hi, my name is Ohlsen. I am the director of Measurement Lab, which is a fiscally sponsored project of Code for Science and Society. I'm joined today by Mathis, Dave Taht, and Christoph Paasch. And today we're going to be discussing three metrics of increasing relevance in the internet measurement community, which are latency, buffer bloat, and responsiveness. Our goal today is to discuss what these metrics have to do with internet quality, what they tell us that other metrics don't, and discuss how internet quality can improve if we make better use of these metrics and what the challenges are to doing so. So to make sure our panelists' ears sufficiently burn, before we get started, I'm just going to read off their bios and introduce them and their work. So Mathis is a senior research scientist at Google and Measurement Lab. Mathis has been working on internet performance research and development since 1990. His work includes measurement tools, models, and improvements to protocol standards. He participated in MLab from its inception in 2009 and came to Google in 2010 to find a larger platform on which to stand. Bonus points if you understand that reference on the last line. So Dave Taht and members of the Bufferbloat project, some of which might be present today, have made vast improvements to the internet and to Wi-Fi as described in the book Bufferbloat and Beyond. I highly recommend looking that up. He has lectured at Stanford and MIT, NANOG, RIPE, Usenex, IEEE, and IETF. His R&D work on AQMFQ technologies on the internet have been integrated into Linux, OS X, and iOS kernels, cable modems, and many Wi-Fi chips, and has created and managed internet improvement initiatives such as Zero RWRT, Make Wi-Fi Fast, Cake, and more. From these projects, we've seen major innovations in congestion control algorithms such as BQL, FQCodal, FQPi, and BBR. And last but not least, Christoph Paasch is a networking architect at Apple and has been working on transport layer networking since 2010, focusing on extensions to TCP like multipath TCP or TCP fast open from specification in the case of MPTCP and research and implementation and large-scale deployments at Apple. Lately, he's shifted his focus on improving the network properties that really matter to end user experience by exposing measurement tools to raise awareness to these issues. So responsiveness under working conditions is now the primary target. So with that, if you're new to internet or to MLab community calls, we host these about once a month. If you RSVP to this one, you'll be invited to future ones. And they're really an opportunity just for the various folks that use MLab data, come across data done with MLab research, and in whatever capacity come together and not necessarily talk about the MLab data, but the research and the work that we're all doing. We also host them as MLab to learn from you all and think about how MLab can be used as a resource in your work. And so, as I mentioned, the explicit goal is to discuss these metrics and in more detail, but the implicit goal is to listen and respond to how one another is thinking. This is not an academic workshop. We probably won't solve anything today, and we might not even learn anything drastically new, but the hope is that by just listening to how each other is thinking and posing questions and provocations to one another, we can have a more shared mental model about the mutual challenges that we're all individually chipping away at within our work, and particularly the big one, which I think everyone here has an interest in, which is how to improve the internet. So to that end, I'll remind us of our community guidelines, just to communicate with courtesy and respect for one another and each other's work, recognize that these are complex topics and treat them as such, so coming at them with patience and an open mind. And even though we're tiny little boxes on one another's screen, treat each other as you would in, quote, real life. So with that, just some housekeeping. You probably or hopefully got a little consent thing when you came in. This is recorded and will be published openly, so just keep that in mind. Questions and comments, this is very much meant to be a discussion, so questions and comments are welcome as we go. Please use the raising hand function and the chat, and I'll bring them in as possible. And the classic 2021 reminder, please mute yourself when you're not speaking. I feel like I hear some background noise right now, so that reminder might be needed right now. So with that, does anyone have any questions, comments, concerns? Okay, great.
I'm sorry, Lai, it's Vince Cerf. I
Hi,
would
Vin.
just like to add one other element to our discussion, which is can these be implemented? Very important to understand whether we have it's one thing to define a metric and something else to figure out whether or not you can actually capture the information.
Thank you, Vin. Yeah, that's a great leading question too. I think first we'll start, we're going to get far past the introductories of these concepts, but I will start by asking our panelists to define them, just so we start with the shared model.
I am struggling to hear. There is still some kind of background noise happening.
Got it.
Everybody, please mute. Thank you.
Thank you. Yeah, and I will ask the MLab folks to try and catch the culprit. Yeah, if you have audio problems along the way, please let us know. Okay, so just to get us started, to make sure we're all operating from the same understanding, I'm going to ask the panelists just to define these metrics briefly. Matt, I'll start with you and giving us a definition of latency to work with.
Well, the first order, latency means delay, and there's a lot of delay in the network that you can't fix, the speed of light and to some extent delays for equipment. But the delay that we're primarily interested in here is queuing delay caused by other traffic in a queue and packets sitting behind having to wait their turn. So that is latency.
Yeah, thank you. And Dave with Bufferbloat.
This is going to be a live demo. This cup represents an adapter between a higher rate and a lower rate. Okay. Typically, I would use a funnel here. I might do. And the way that we do signaling across the internet, here we go. You have this adapter, and then when it overflows, as you saw there, that signals back to the center to slow it down. But you see how long this is taking to drain. That's Bufferbloat. Having an adapter that's so much larger than the actual rate that you're using, that you have really drastically reduced interactivity and many other problems. When we started the Bufferbloat project 10 years ago, a typical size buffer was a bit larger. And we've had to develop really smart algorithms to try to modify the size of the funnel to the actual output rate, particularly for things like Wi-Fi and cable modems and other edge technologies, to actually create a dynamically sized, correctly sized amount of buffering to keep the flow going smoothly. So that's Bufferbloat in a nutshell, in a funnel.
The live demo it went quite well. We were worried. Okay, and Christoph, if you can give us a definition to work off of for responsiveness under working conditions.
Sure. So responsiveness, or as you said, indeed, responsiveness under working conditions basically brings both together, the latency and the Bufferbloat. And what we measure there is, with responsiveness under working conditions, is how much latency is the Bufferbloat introducing to the communication from client to server. And we call it working conditions because any data transfer on the internet, whether it's just sending an email, receiving an email, sending a photo, receiving a photo, puts the network in working conditions and creates those tiny bursts of Bufferbloat. And so measuring responsiveness means you put the network in working conditions, which creates Bufferbloat, and then you measure the latency. And so that is what we call responsiveness.
Thank you. Yeah. So, I mean, maybe we can just hop right into it. What are the challenges that are presented when thinking about how to measure these metrics? And I'll start with Matt, but then everyone can hop in. Oh, Matt, I muted you earlier, so I used my superpower. You might need to unmute yourself.
And I wasn't paying attention. I thought it was quiet here. Yeah, so for me, the really hard problem is that is actually not a technical problem, it's a policy problem. And that is, there's been lots and lots of discussion between engineers about Bufferbloat and causes and so on. But there's nothing to convince the people who control the money that it matters, because they don't understand it. And the people who are making business decisions, the people who are making marketing decisions, don't tell the engineers to go deploy the stuff. The engineers know how to do it, and the engineers can't get budget to do the work. And so what is happening here is I think is we have a perfect storm for getting this changed. Christoph has a tool that he will talk us about later, but it's basically a user-facing tool which can measure buffer bloat, can measure responsiveness. I believe that MLab can easily deploy, no, I shouldn't say easily. MLab can deploy a responsiveness metric that it can be run alongside or as part of its performance tests. And the two of these have in combination the property that you enable a large number of users to complain at their marketing people about things that they don't like. And the engineers can see measures that are comparable to explain what the users are talking about. And that will cause the money to flow in the right direction to cause the problem to get fixed. So that's my view of the hardest problem.
Absolutely. And maybe to latch on to what Matt said, in the tools that we are now exposing, and maybe this is, I don't want this to become just talking about Apple, but maybe I will just quickly describe what we are exposing here. In the upcoming iOS release, when there are two ways one can measure buffer bloat or responsiveness, which is the term we prefer these days. It's first one, if it's the developer phone, it's in developer settings. You can just go in there, tap a button, and you measure the responsiveness. And it will be measured in terms of round trips per minute. And I'm sure we're going to talk more about that later. The other way is you can go and install a Wi-Fi profile, and then it will also show up in the Wi-Fi settings, and you can just measure responsiveness in there. Now, this is very hidden, of course, in iOS, and on the upcoming macOS release, there's basically a command line tool available that measures throughput, upload, download, and the responsiveness as well. And as well, again, measures it in round trips per minute. And so that way, our hope with this exposure that we continue working on is, as Matt also described, is to provide everyone, the users, to raise the awareness to users, a tool to measure responsiveness, and then also a technical tool like the command line tool for the developers, the equipment vendors, the ISPs, for them to go and test their responsiveness in their network on their devices, and then go and fix it, right? We are working on open sourcing the server side of this story, and that's going to happen in the coming week or two. And so then we hope that people can deploy it in their own lab and just use a Mac with the upcoming release and measure responsiveness in their lab environment.
Thank you. And to the point of awareness, what are you all hoping that the user is able to become more aware of? Or another way to say is, what does responsiveness as a metric tell the user that, say, throughput metrics don't necessarily? I'll direct that at Dave first.
Why is my internet slow today? And am I still here? I just dropped out. I see a rich brown all screen there. Why is my internet slow today? Well, this gives you a perfect explanation as to why. Oh, there's an upload happening. The other thing that I'm really liking about the RPM style metric is that it also gives you a chance to do an A/B test. And that, oh, wow, my responsiveness is that. Well, what happens if I do put another better router in place? Oh, wow, it goes up by, the responsiveness goes up by a factor of 10, and that's something I can actually feel. And I'm hoping that vendors will say, this particular router has a responsiveness of this under this load under this working conditions. And I would hope very much that we see a uptake for all the people that are stuck at home. Go update their routers after understanding responsiveness better.
And one of the things we need to do as a community is make sure these tools don't cry wolf, because that annoys the ISPs. Tough. And why it's absolutely perfect that this is rolling out in Christoph and the developer training. We'll get some field experience where the people will learn how to turn it on. The gamers will figure out how to turn it on because it's already in the videos and the Apple developer videos, and so people will experiment with it, and the ISPs will start to hear about it too early. AmLab will be in a position to deploy it at scale at some point. And when that happens, what I would like to see is every time you run a speed test on Measurement Lab, it gives you the bandwidth and it gives you responsiveness, and just unconditionally give you both of those. And we're actually doing a slightly different definition of responsiveness, but we believe them to be parallel. This is one of the things we haven't vetted. Both of them are counting round trips. MLab will be counting round trips at the TCP layer. The Apple tool is counting round trips at the application layer, which includes the stack delays. And so they're both useful metrics. The Apple metric is more relevant to the users because it feels application performance. The MLab measurement will be more relevant to ISPs because it doesn't include as much of the end system effects. So I'm excited about this.
The hope really is with the tooling is because we have often meetings with vendors and so on, talking about different problems. And at one point, somebody told us when we were working on, when we were talking to them about this tool that we are working on, is like, when you do this, what will happen is people will start to optimize for it and create micro benchmarks around it. And we are like, yes, that's what we want. That's what we want, because what cannot be measured, right? What cannot be benchmarked, micro benchmarked, is not going to be optimized for. So by exposing the tool that puts the number right out there, so this is your score. If you want to get it higher, you need to do X, Y, Z. That's how we hope that we can move this. And so we hope that, yeah, MLab, a speed test, maybe even inside Android, it could come up a tool that to measure responsiveness, Microsoft on Windows. That would be awesome.
So we have a good question in the chat. Are there write-ups for each of the responsiveness calculations, and can we get links? So yes, one on the links, but also maybe you can just talk more a bit about how responsiveness is calculated within these tools. And probably Christoph is the right person to throw that at.
Sure, Jake. So we are working on specifying the methodology that we are using, specifically for the responsiveness under working conditions, the way we do it on iOS and macOS. I can send you later the link to the ITF draft. But maybe to quickly explain it, how we are doing it. First of all, as Matt explained, our focus is on users. So we use standard protocols that are most likely to being used by end users, which means today HTTP2 and tomorrow it's going to be HTTP3, right? Quick. And so with multiple HTTP2 download and upload streams, we are putting the network under working conditions, which then basically triggers the Bufferbloat condition that we are then trying to measure. And again, we don't measure with ICMP pings because often they are prioritized and so on. And so you don't end up measuring the right thing. We are measuring with an HTTP2 GET simply for a very small file. And so we measure the real application layer latency. And we use these numbers, squash it all together, and then we compute it as round trips per minute. And why do we do round trips per minute? And we call it RPM. The reason is twofold, or many reasons. One of them is we want to have a metric that is the higher the better, right? Because that way we can optimize for it and make it higher and improve it. Second, why not round trips per seconds? Why round trips per minutes? By having round trips per minutes, the range is pretty nice actually. The range goes from, let's say, very bad networks in the 50s to very good networks in the 6,000. With the round trips per seconds, it would be decimal numbers, and we don't want that, right? So that's why we use round trips per minute. And so that's how we use it, at least currently in macOS and on iOS. Now I see you found the ITF draft. We don't claim that this is the only way and the best way to measure responsiveness. It's just one way, and we would love to find the better way. And so we encourage everybody to contribute on that draft to see how we can make it better.
And Matt, you spoke a little bit, I'm assuming everything that Christoph, you just talked about was with that application layer. And then yeah. Matt, you referenced the TCP layer implementation. Is there a difference in how that is calculated?
So the way I'm calculating responsiveness for the TCP layer is by using the smoothed RTT, which is the algorithm that Van Jacobson specified in 1988. And it's actually the It's essentially the harmonics, 1 over the harmonic sum of the smooth RTT is the mathematical description. But what this is an estimate. If you took the protocol sequence diagram for the TCP connection, which typically looks like a bunch of diagonal lines between 2 vertical lines is the way that people draw it, is counting the rounds in that diagram. It's counting the number of times data triggers an ACK triggers more data. It's the round trips in the network. It's between, since it's inside of the operating systems, it's actually between the software interrupts usually at the 2 ends. And so it doesn't include any applications or anything like that. It very much is focused on the network. But the way we're calculating it, so that's a definition of, I'll say, TCP layer rounds or TCP layer RPM. The way I'm estimating is by using the TCP's smooth RTT estimator, which has been pretty much standard for the last 30 years, 40 years. It's been, the parameters have been tweaked slightly, but there's essentially the same estimator, and MLab has has more than 12 years of archived smooth RTT data from all of the TCP flows. And so we're looking at tests, and I will send out another copy of a little paper that I'm working on that describes exactly how we do the measurement and so on. But this is primarily a networking layer measurement. It doesn't care so much about the details of how other things work. The real answer to Toki's question about the document is we're actually at the stage now where I would say that we're comparing. We don't want the ink to dry too early on the specifications. We want to make sure that we understand exactly what the relationship is and don't make any mistakes. The TCP layer metric, for instance, doesn't need to do anything to create cross traffic. The MLab connectivity is strong enough where you essentially always cause queuing delay, unless there's some really egregious bottleneck, which is not a network bottleneck. And so a single flow from MLab, we run at 10 gigabits per second potentially, always causes a queue someplace. So that was my ramble.
Matt,
a lot of stuff there.
I have a quick request since that's coming along. There was this network outage. Level 3 went down like 4 years ago for 90 minutes. If you have any samples from that, you can run through this. It would be great.
In GitHub, there's an issue which includes a query which brackets that. If you learn how to use BigQuery, you can go find that issue and you can ask your own questions.
Wow, way to ping pong it back. We had a good question a while back from Greg Russell about how is this different from RTT or min RTT. I feel like that was in relation to responsiveness as a metric, but Greg, if you want to clarify. And then Christoph.
Or actually more specifically, so I agree, it's nice to have a metric that goes up when it gets better. And I've talked with this a lot with Matt, but maybe this is, I would like to prompt a clear explanation. Is this actually different than 1 over min RTT or 1 over RTT or 1 over something else that we already have?
So I said earlier, it's 1 over the harmonic mean of the RTT, and it's the sum. It's actually kind of cool. The MLab gets samples of the TCP state every 10 milliseconds, roughly every 10 milliseconds. They're somewhat irregular, and sometimes you miss samples, and sometimes they're late, and whatever. And so it's for each sample, you estimate the progress in rounds as the sample duration over the smooth RTT, and you just sum that up as you run down the connection. So it's a real straightforward calculation. I can do it in BigQuery, and so I can add this column, which is the responsiveness, to the BigQuery data years after the experiments were done. I can also add the same calculation in the server and provide the same number in the server. And so I have a way of calibrating the data from all of our historical data, and I have a way of imagining plumbing through a new metric in the current server without changing the wire protocol, except to add one more column, one more field in the output. So it's really nice.
So then I have a follow-up, if that's okay.
Yeah.
Which is, this seems as if the harmonic mean de-emphasizes long pauses, bad jitter. Right?
Correct.
If I've got fantastic RTT for 90% of my connection time, but I'm getting these periodic 1 second dropouts, it still looks pretty good in this metric.
True. And so this is where you need to pay attention to the fact that there's actually different metrics for different things. This is not a jitter metric, and it may not accurately predict how the gaming experience would be, because that kind of event would be an absolutely, you pull the trigger and then that is the second that you get the extra second pause and you're done. And so it's a different time scale, and it's so the people who measure jitter say, average is a horrible metric to use. What responsiveness measures is actually accurately represents things like complicated page load times, because the page load in a web page depends on a sequence of events, and each event is triggered by some preceding event. And so the time it takes to finish loading a page is actually exactly aligned with the responsiveness metric. And the responsiveness metric is an average over the duration it took. I mean, we're doing a 10-second average of something that will give you an accurate answer for something, for a page load that happens to take 10 seconds. Now that's today's internet, that's kind of a complicated page, but.
So I have a question from Vint along these lines.
If I need to.
Greg, I'm gonna interject with this question. So does RTT smoothing lose estimates of jitter, and do we need something for that also? And then Nick Kingster added, especially in measurements, we see lots of RTT variability, especially under load. And maybe I'll go to Christoph for this first.
Yeah, in terms of the variability, especially on a load, what Nick mentions, yes, absolutely, we see this as well. It is actually very difficult to reliably load the network. Surprisingly difficult to make it in a way that it is stable during that time during which we want to do the measurement. And so ideally, such kind of measurements would last for a long time. You would load the network for more than 20 seconds, for maybe a few minutes, and during this time continuously measure the latency, and maybe that way you can weed out all the variance. For us, we are focusing on making it a quick test, less than 20 seconds. And so there's definitely a lot of variance. We see things happening like synchronized packet loss, which all of a sudden the latency goes lower during that time. And so, yeah, it is very difficult. And the way I look at it personally is like this responsiveness kind of measurement is a quick indicator of how bad the network can be. It's not the reliable, okay, this is the absolute number and it's a stable number. It's more like a quick and dirty measurement.
I'm going to go to
Dave, something.
Yeah, I'm going to go to Dave, and then Bob will get to your questions. So Dave.
Okay. One of my pushbacks over the years has been a single number summary, averages, there's no meaning, all that stuff. Single number summaries don't work. So I live and breathe and die by graphs. And in particular, CDF plots are the things that I do. Training end users how to read a CDF plot does not seem to be in the cards. But we have managed to train users to blindly not see the actual speed test results. If you look at a typical speed test plot, which does increase in bandwidth over time, you see this curve. And then speed test reports the last number in the curve. A certain company, I probably shouldn't mention, has optimized their network for speed test. So they get that really good number at the end of the curve. So it'll be really marvelous if along the way, somehow, we can show the beginning and the end of the curve as well as jitter happening in there, and get people to focus on that, not just a single number.
And Bob, you had a slew of questions if you want to hop in.
Yeah, I have a handful of questions and a comment. I test a lot for Broadcom, and so if I need to provide sort of metrics and units that are actionable to the engineering team in a way that they can basically are actionable. And so if I give them a complicated test, using a complicated protocol, they don't know what to do with it. So the first thing that's confusing to them is how is delay, which is units time, versus some 1 overtime type metric, when they're measuring delay on everything they do, right? How long does I get Wi-Fi access? Everything's in units time. And now we've inverted it, and it's confusing. The other part is that, the network power metric is throughput over time. And now we've inverted that. So, and then back up with RTT is, everybody's halving RTT to get one-way delay. Well, that's never true. So it's always one-way delay.
I only have a 3-packet deep buffer.
Right.
But
So,
yes, it's network power, but nobody knows what network power is besides the people in this room. Maybe not even.
yeah,
most of
but
us.
for my engineering, I can work with that. Right. So I don't know if this is a consumer thing that then we send it out and say, hey, consumers gave these numbers, and our guys are going to come back and say, I don't know what to do with those numbers. At the end of the day, we've got to get back into the lab and fix problems. Right. And I need those hard measurements. And so,
it's more important that the metrics are sort of intuitive to the end users, because you don't have an opportunity to explain to them. The engineers can do the math. The engineers, I've actually been aware of a very similar problem just on the units. As network geeks, we all use bits per second. Nobody else uses bits per second. Nobody knows what that means. And I once gave a presentation to a bunch of networking people where I did the entire presentation. Whatever, or I did the entire presentation in bytes instead of bits, and it was amazing how much it stunned the audience. It's like, what are you talking about?
I'm having a hard time converting that a user, my daughter, pressing a button and getting a number and having 1 million of those come to us and say, okay, I got 1 million of these numbers, and handing it to my engineers, and they're like, I don't know what to do with that. I've got to produce a test environment.
But it's strictly speaking 60 seconds over a mean of the RTT.
Yeah.
I mean, that's all RPM.
And that's the RTT is, and it's not a one-way delay. It's a round trip of the thing.
It's round trip, and it's
all our Comcast asymmetric links where
it doesn't matter for responsiveness. The asymmetry doesn't matter, because it's actually the number of interchanges in a conversation under the web browser.
Yeah, but it matters from a bloat, right? Because it tells you the bandwidth delay product, which is driving the congestion.
Bandwidth delay product depends on both the forward and the return path.
So Bob and Matt, I'm going to hop in here and ask Rich to unmute and ask your question, and then we'll go to Vince.
Okay, I think I am unmuted. I'm going to advocate very strongly for a consumer measurement here. People, I've been trying to explain Bufferbloat to people for a long time. People don't get it. I'm not worried about the network engineers not getting it. I see Dave's toy there. What I need in order to help people talk to their vendors, and whether it's an equipment vendor or router vendor, or whether it's their ISP, I need them to say, I need them to say something besides my network is slow, because the proper response of any responsible vendor is to say, well, you need to buy our faster thingy. The answer is not to buy something faster. The answer is to fix your stuff. And if all of a sudden everybody started calling their ISP and their router vendors and saying, wait a minute, your stuff's not responsive, what can I do? And the product management starts hearing the responsiveness of our XYZ model really stinks. What can we do about it? They then can talk to the engineers who can say, wait a minute, they're using this RPM thing. What's this RPM thing? Oh, wait, this is just measuring responsiveness, measuring this is in fact 1 over latency. Oh, is there anything that can be done about that? Oh, it's been solved for 10 years. I'm sorry, 9 years. And maybe we can roll this into the product. So I'm done. That's my rant. Thank you for listening.
Rich, thank you. I'm actually going to
Thanks,
ask Vint and Nick maybe to present the questions that they've been throwing in the chat. There's some good agreement there. Maybe Vint and then Nick.
Vint?
Can't actually see Vint. Vint, are you? There you go.
Well, it's Vint. I didn't know that you needed me to say the questions. Is that because there are some people who can't see the chat?
Oh, it's just more for if people are not following the chat, and also just to get folks talking to one another. So if you don't mind introducing what you're presenting there.
Well, actually the correct response is pay attention to the damn chat. It's sort of like RTFM, right?
Sure.
Okay, so a couple of things. The most recent thing I put in was the notion of circular buffers. I used to use those a lot when I was still programming as a way of looking into the brief past to find out what the hell just happened. And I wonder whether we could consider doing something along those lines. Second thing is that if we had some way of doing background measurement all the time, which I gather we do, in some cases, that's also very helpful, because then we can turn to that and say, what does performance look like over time, or what does it look like in the recent past in the event that we want to identify a particular condition.
And I think, Nick, you had some thoughts on that as well.
Yeah, I don't have too much to add. I think that Vint makes two very good points. I think it would be it would be interesting to discuss in relation to a temporary circular buffer, whether we could normalize some kind of measurements of application traffic. What's going on with a web page download, what's going on with this video stream, et cetera, in addition to injecting active probes into the network. I'll keep it short. I think the other point to Vince on the continuous measurement, like yes, times 1,000. I mean, we see so much variability by doing continuous measurement that don't get picked up by just points in time. Super, super valuable. One thing I'll just sort of add on that are the asterisk. If you want to do stuff like latency under load continuously, you've got to load the network periodically, and loading a gig link uses a fair bit of data. And I now regularly exceed my data cap at home because I've turned my home network into a lab. And so just something to keep in mind as speeds get faster, some of this stuff, if you're going to do it with any frequency, does run into perhaps not just the resource waste issues that Vint draws upon, but also data cap kinds of issues.
I see Dave has been doing an actual dance to hop in here. So
I was
go
hoping
ahead.
Matt was going to jump in, but maybe I'll jump in before Matt jumps in. I am very pleased that we now in Linux have the TCP_info structure so well defined and capturing so many wonderful statistics today. And we really could, for Linux-based applications today, instrument that circular buffer for nearly every application and construct a lag meter and also extract jitter from basic foreground traffic, but not by driving the network, but by actually measuring what's actually happening. And we can also get away from smooth RTT as a metric there as well, I believe. We get min RTT out of that. I also want to give a big thing of thanks to Matt about Web 100, which was a preferred product he did. Back to you, Matt.
Yeah, let me say, so more than 20 years ago, I was the architect of a proposal that became the Web 100 project. And the point of Web 100 was to have always on instrumentation in every web server. It was an explicit intent of the project, starting in, the proposal was written in 1999. And we didn't understand how to estimate the cost of some of these metrics. And so it never made integration into the upstream. TCP info actually explicitly borrows some of the metrics that we designed from Web 100. The intent was to have always on metrics. A lot of applications on a very, very, very fine scale let TCP run as fast as it can. And you actually get in ordinary web serving and stuff like that, object come down. Even video in Dash, depending on how you do it, Dash typically sends chunks of video at maximum speed. And each chunk of video, it's 5 seconds worth of video, and it might be a second of network time. It is a measurement of the network, and it cranks along. And the point of TCP info and Web 100 is you can actually extract data from all of that. One of the oldest experiments on MLab, which was one of my experiments, was an experiment called SideStream, and it just did that. It listened to every single TCP connection and it actually only got exit statistics, not periodic statistics, from every single connection on the platform, and it just archived it. It's like, and we've gone back and mined that data for things. It turns out that there's a bunch of connections to port 22 that are kind of interesting and stuff like that. But this was always the intent. I don't know. I'll leave it there.
Let's see. Christoph, yeah.
I want to make one comment on the questions behind passive measurement in a circular buffer, and then also I think I saw another comment which was about, oh yes, I think Nick made that comment about active periodic measurements. On the passive measurement side, what I'm under the impression is that one of the problems is that we won't be pushing the network to its limits. Just to give an example, on iOS, the moment you start a FaceTime call, all your TCP traffic that is not foreground is going to be slowed down with LEDBED and receive side LEDBED. So we try very hard, because Bufferbloat is a serious problem, we try on iOS very hard to avoid it. And so it can, by doing passive measurements, it can become very difficult to actually find those particular problems that are out there, because we're no more pushing the network to its limits. With an active test, you can actually push the network to its breaking point, at that point to think, okay, that's where the problem is. That's the particular issue in your network or on your device.
So in Measurement Lab, we get the receiver window, and we will instantly see that. And now that I know that this happens, I will look for it in the data, because we will see the pushback. And the question is then, how do you mark the data? That's like, well, if somebody was running an MLab test while running FaceTime, and show it up. I think you should call on Jason.
Yeah, Jason, we have a hand from you.
Sure. So I think before folks were talking a little bit about motivations for improving the situation, and one way to do that is through consumer-facing measurements, things that are higher numbers like RPM. That's great. What are some other things that you can do to help motivate deployment? And I'd like to suggest one that is entirely non-technical, which is that, at least from a US standpoint, many people completely misunderstand things like active queue management as a form of prioritization, and fear that deploying it or talking about it will lead to a claim of violating net neutrality. And so I would just sort of say it would be helpful for consumer advocates, measurement researchers, and others to make clear, when talking about things we can do to lower latency, that deploying AQM is a great thing to do and will help the situation. And by the way, AQM and lowering latency is not prioritization. And by the way, it doesn't violate net neutrality. I am speaking very directly. Those would be very helpful. Thanks.
That's important to know. I actually, through the history of MLab, have occasionally pushed back on experiments that were planning on publishing information that I thought was bashing ISPs for doing things that I thought was good engineering, and I've really worked hard to prevent some people, for instance, for saying that shaping was evil. It's like, no, if you want to do a work conserving network where a small user gets unfettered bandwidth and a big user gets a fair share of the average bandwidth, that looks like shaping, and there's no way of implementing those constraints without it looking like shaping, and that's actually good, efficient network engineering.
Can I actually
ask discriminatory?
We introduced a new concept here, AQM, and just for one of you maybe to describe how this relates to responsiveness, maybe Christoph.
Sorry, can you repeat the question again?
Yeah,
Sorry.
how does AQM?
I think you should have Dave do that one.
Yeah, Dave also too. Both of you. So let's start with Dave and then go to Christoph. How does AQM relate to responsiveness?
Going back to 1992, we decided that we needed a working active queue management system on the internet. And what that does is it takes a look at the depth of the queues and tries to shoot at packets to slow them down, to signal the other side to slow down the flow so it doesn't hit your interactivity as much. The goal in life is to have just enough buffer. You can go back to my demo to keep the flow going, but not so much that you're waiting seconds for things to happen. So the product of the last, the core activities were from 2011 to 2013. We developed working, finally, 30 years later, active queue management technologies. And they've been deploying, and yet we have met a great deal of resistance from network neutrality folk that think that actively managing a queue, a technical term, is possibly bad. And we really do need, not just we need to have a unified front of network experts and ISPs and the governments and everybody else to say, no, active queue management is really good. Here's a demo of why. You should be able to show a network neutrality advocate an A versus B of a Comcast prior to Pi, Comcast now with Pi, and say, oh yeah, that was good. And have that united front to not only upgrade that network, but all the networks of the world. So that was a bit more of a political rant, not really describing what active queue management was or fair queuing or anything else. But go ahead, Christoph, you can take it from there if you like.
I want to echo on what Jason also said, is like, people need to understand that there is actually a problem, a solution to the problem, because we had countless conversations and then we got the feedback, yeah, we'll just do prioritization. We'll just create a separate barrel on 5G for the low latency traffic. And we're like, no, all traffic is low latency. And people literally have a hard time believing that it's actually possible to achieve low latency while loading the network, while basically actively using it. And it's very—
it's outside of most people's experience. It's just for us old farts that did fair queuing and AQM years ago. 20 years worth of users are used to the network going to hell when they do anything on it.
Periodically, we run into providers that think every packet is sacred, and they work really hard not to drop them and don't understand that that means you get these ridiculous delays because TCP keeps pushing until you do something to it. And
you have your Windows scaling story versus your kid.
Oh, so when we were doing the Web 100 project, so one of the things that came out of the instrumentation in Web 100 is we figured out how to do receiver-side auto-tuning. And so we were deploying receiver-side auto-tuning. And this was in the early 2000s, we were explicitly, in the release notes, there was explicitly instructions to look out for weird symptoms of auto-tuning in TCP. And we didn't have the words at the time, but what we were fishing for was things that looked like Bufferbloat. And we didn't run into any. We didn't find them and eventually the code went upstream, and we had a conversation with Microsoft. We can convince them into deploying, working on receiver-side auto-tuning and so on, which was because my comment was the internet will be broken until you guys fix your stack. Please go follow our footsteps and do this stuff. I'm not interested in patents or anything like that. You just got to do it. And they did. So one day, my son, who knew I was interested in performance, he was doing some web support, and he said, Dad, how come I've got this brand new Vista machine, and every time I upload a website that I'm managing, all of the rest of the machines in the house stop being useful? It's like, oh shit. And it turned out at the time, and we didn't discover this, but by hindsight it appeared, the OSs before Vista, the loss recovery code was clunky enough, and they had a fixed receiver window for the Windows stack, had a fixed receiver windows. The optimal way to get performance was to put as much buffering in the modem as possible. Because what would happen is when you hit a web page, it would basically load up all of the non-block parts of the web page into the queue in the modem, and it would drain into the Windows machine, and you would get optimal performance. So there was independently the deployment of auto-tuning in Linux in web servers, and the deployment of Windows-friendly queuing in modems, and the combination of those two is Bufferbloat. That the auto-tuning in the servers fill these huge queues, needlessly large queues in the modems. So, ouch, we missed it.
So next, let's go to, let's see, we have Greg and then Bob and then Nick. So Greg.
That was so long ago. I had originally raised my hand basically following one of Dave's comments about multimodal or distributions versus single statistics. And actually, it's probably worthwhile circling back to that because I think it's an important point that covers the entire dialogue we're having. And while I'm a huge fan of showing distributions or at least examining distributions rather than trying to summarize single numbers, the reality is that from a social acceptance point of view, single numbers get a lot more traction than trying to use distributions. And so this is one of the reasons I'm very interested in whether RPM is the right metric for us to be promoting, because it takes a lot of energy to get a new metric into the public sphere. And if we pick the wrong one and we're unhappy with it a year from now, we'll be unhappy.
I would say that's why we don't want.
I think it is really important to come up with single valued metrics that are really meaningful and correlate well with people's experience. And we should be looking at that a lot from the user perspective instead of from the engineering perspective.
Let's go, Dave, and then Matt.
RPM's actually the thing that users are going to care about.
Dave?
I just wanted to say something. This is precisely the question why we don't want to let the ink dry on the specifications until we've actually got some field experience with the metrics. And we're in a situation now where we have a couple of developers that can talk to each other and can actually do the experiments of, do these metrics mean similar things? Do these metrics have parallel results? Do these metrics calibrate each other? And so we can have confidence in what the metrics are going to be authentic about before we commit the ink to standards. And that's actually important.
Absolutely. We're having a good dialogue now. We're trying to do the writing now. We're trying to find people that can help now. Contributions are welcomed. But I wanted to go back to your point. I do not like single numbers, but you can do a RPU, revolutions per microsecond, and then plot that. You could do something that would be more meaningful to an engineer. And also RPU, for example, would be something that we would be able to see gaps and jitter from as well. So I hope is that internally the tools will be calculating this stuff at the finest possible resolution, but reporting back something that a user can understand.
Bob, your hand was also from a while back, but if you still wanted to ask your question.
Yeah, I just wanted to, talk about our chips, our Wi-Fi chips and our NICs and our switch fabrics, but mostly the Wi-Fi chips are on every platform you can imagine, right? And so one of the challenges I have is if you give me a complicated test for some, set top, it's going to be difficult. So the question, can the test be defined in a way that's closer to TCP state machines and to socket calls? And because those I can realize relatively easy. But if you say I got to do an HTTP, or even wgets and stuff like that, it's going to be more challenging to get onto a lot of these platforms. And so for my view is I got to get on every platform that carries a Wi-Fi chip, every single one. So that's a pretty good size chunk. So if anything you can do along the lines of sort of putting it at a lower layer with open source code would be great. So maybe your thoughts on that.
Yeah, absolutely. I mean, responsiveness can be measured and round trips per minute can be measured at many different layers, right? There's the HTTP layer, Matt is focusing on the TCP layer, right? And depending on which platform you're working on, like for your case, right, would be Wi-Fi chip. Well, the TCP layer responsiveness metric is perfect, right? If you're looking at a consumer end device and you want also your web servers to be responsive, while the HTTP layer metric is more relevant. So that's what we are looking at, is that, okay, how can we define responsiveness and counting rounds in a way that it becomes such that you can do it at many different layers, right? And maybe Matt can give more info into this, into his ideas.
That's the perfect answer. And the metrics are parallel, but they're not identical. And that's the engineering metric has got different constraints for goodness than a consumer metric. And
can you elaborate on why I have to use HTTP and it can't be defined at TCP? Because fundamentally HTTP is used.
So you don't have to use HTTP, right? That is our point. Is like, sure, the way we at Apple define it was by using HTTP, because we are focusing on consumer metric, and there can be a metric that is focusing on TCP, right?
Okay, but when there can be, because we're trying to get it to an industry standard metric, and you're saying there can be a metric that's focused on TCP. What I'm looking for, can I have that metric that's defined in terms of TCP sockets that's analogous to what you guys are doing, so I can get it on all my platforms? And that's know that this is the industry standard metric that everybody accepts across the world.
so I haven't done research on that, but one of the philosophical consistencies of the IETF is one of the first things they implement in any protocol is a ping. And there's a ping in HTTP, there's a ping in WebSockets, there's TCP echo, and all of these things are different versions of the response or frameworks which could be used to measure responsiveness at different layers. But yeah, the old port 7 TCP echo service could be used to provide a responsiveness metric. It turns out that to calibrate it, I mean, I just thought about this for a few minutes at one point. Calibrating is a problem because it depends on the size of the copy buffer, because you need to do a read and then a write, and the size of that buffer actually matters in terms of how it affects the responses. And so it's not trivial to do, but philosophically, the IETF always implements echo in every protocol. And that means any protocol can have a responsiveness metric.
I guess what I'm asking for is, I think that my understanding of the purpose of this meeting is to talk about a specific metric that we're trying to push across the industry, not what ping does, not what other things do. So on this specific metric, can it get defined in a way that I can realize it with TCP socket calls? I don't care about ping or ICMP or HTTP. I care about this metric because I want to deploy it everywhere.
So the purpose of this metric is for us to look over each other's shoulders and see what we're working on, and it hasn't congealed yet.
Okay. Okay, so we're still in the early stages to find the metric. I don't really know exactly.
Right. And so each of us has written down, or has at least to ourselves, if not in a shareable way, a precise definition of what it is that we're doing. And at some point we'll be cross-calibrating them.
Yeah, put in context, what I'm being asked for right now, tomorrow, after this meeting is, Bob, what is the metric doing? We want you to implement it so we can fix our routers. That's what exactly it is. As soon as I tell them, here's the metric, you don't have to wait for, your user.
So
we can tell what the metric is, and I'll tell the engineers, this is the metric, here's your bloat, fix it. Right?
So
Matt, go ahead, and then we're gonna move on.
I would advocate the TCP layer one because it depends less on the details of the software. The application layer one is more authentic for users, but the stacks introduce a huge amount of delay all on their own, and there's a lot of difference in how it manifests itself. The applications introduce delays. I mean, this copy buffer issue, for instance, is an added source of delay. And so there's a bunch of challenges there. It's also the case that with a single TCP stream, MLab has no problems in a global internet of always causing a queue. To the first approximation, a single TCP flow running at as fast as it can always raises the delay, often causes loss, often causes ECN marks if they're turned on, and might fill an application unless it fills an bottleneck in the end system. If it doesn't fill a bottleneck in the end system, it absolutely has to raise the delay or raise the loss rate or something. And you look at the data and it does. Every single flow shows some signature of some bottleneck.
So Jake, I think you've had your hand up.
Yeah, thank you. I actually was kind of trying to respond to Bob also. I think we really should take a look at Vint Cerf earlier had a suggestion about the if you had he called it a WTF button, but you could easily imagine sort of a user experience is a problem, and then you've got like a minute to press the WTF button on your browser. Now, if you standardized an OS integration that was like, you could, from the client side, if you dedicate 125 megabytes, then you can hold a gigabit. That's a second at a gigabit. Even if you're capturing the entire packets, which you don't need to do probably. Supplement that maybe with QLog with the quick for quick analysis, and standardize some kind of a reporting metric. This would be a really good topic to work on for just making it accessible to users to be reportable. And if you standardize the OS interface, you could standardize a browser interface as well that people could just use, and then configure their reporter. Right. This would be a really big step forward for, and the point is that I support the direction you've taken on this. You want to get the consumers to understand what they can do about it and to understand why they care first. And then like the network engineers, I feel you, Bob. Tomorrow is pretty soon to be giving solid answers on what the network engineers should be doing. But in the end, if you've got PCAPs, then and QLog output, then you're going to be able to do something that's a good solution. So like, get that into the engineers' hands, and the rest will come together. But it has to come from the end users. That's it.
One of my tentative to-do items is something that can count rounds in PCAPs. So you could do the responsiveness directly from the PCAP file.
So we have two really strong threads in the chat right now. One related to Quick and just how I think these metrics evolve over time with new protocols. But one also on AQM, just kind of sustained from when Jason introduced it. So if we want to go back to that, maybe we start with Sasha and then go to Nick.
I think what we're talking about in the chat is really the disconnect between.
Sasha, you're a bit quiet. Would you mind getting closer to your mic?
Let me see if I can fix that here.
And or just yelling at us.
It is. Let's see. Is this better?
It is better.
Yeah. For some reason, Zoom upgraded and now it breaks on Linux and lowers the input volume. But what I was saying is, I think what we're discussing on the chat is really these alignments and differentials between newer technological realities of things like AQM and concerns, I think, stemming from historical precedent, which is that prioritization and other metrics or other mechanisms in the network have been used to kind of disempower consumers from making decisions. And, I thought, for example, the results of what Jason was writing about in his paper are quite compelling. And anyone that hasn't seen that, I would recommend that you go and take a look at that, because I think that is a huge potential boon to consumers. I also worry about, the operationalization of these technologies. And into that space, obviously, would be where regulatory oversight, might set some rules of the road. But I'd love to learn more. And I think I'd love to see sort of a gathering, as it were, of some of the experts that understand the ins and outs of things like AQM. This lies, even as a technologist, at the edge of my ken. And in essence, how we both implement great ideas like that while also ensuring that these powerful tools aren't used for nefarious purposes. And I think we can absolutely accomplish both. I think we just need to be a little thoughtful about you know, setting some rules of the road for them.
Yeah.
So Nick, and then I know Vint, you were involved in this, if you had anything to say.
Hi there. My comment goes back to like 1052. I think Greg had a comment in the chat about, he said users who basically ignore AQM. And I think actually that made me think of this other elephant in the room, which is application under constrained network conditions. Different applications behave very differently when they compete with other applications. They compete with TCP applications. So I noticed my PhD student Kyle McMillan's on the call, so I'm going to brag about his work for a second. He basically recently completed a study that's going to appear in IMC on video conference applications. I just put it in the chat, and I would refer anyone who's interested in these competition issues to section 5. To give just one example, under a constrained link, we saw Netflix open 28 TCP connections in parallel, including more than 10 concurrent connections. And then there's a lot of other good stuff. I would refer people to like figure 10 and stuff, but he looked at how different video conference applications compete with one another. There's a reason Zoom does so well. I'll leave it at that and leave you to read the paper. But I think there's like there's an excellent point.
Hi, Big D.
AQM is great. We're talking about connections and connections that pay attention to them and applications that behave in ways that are fair to one another. But now applications are not single TCP applications. They're not single connection. They're like N connections, and there's no policing of that. So I'll leave it at that and see if anybody else has thoughts there.
Yeah, I consider this bad application design, and whenever I catch it inside of Google, I try to complain. There's actually a lot of other people, including Van Jacobson.
Yeah.
The real problem is the myth that since TCP prevents congestion collapse, the applications don't need to worry about it. And they don't understand that, in fact, the applications can create congestion collapse all by themselves.
So I wanted to reply to Sasha's point. I think Vince is queued up as well. I so strongly support openness and publication of the actual statistics of things like drops and marks, the differences between flows. Those absolutely must be exposed to the end user. I don't like even using the netizen, not the consumer. The netizen needs to know what's happening, and the netizen should be able to prioritize and understand how their own traffic is working if they want to get to that level. This is something that, an ISP can certainly offer a service, but that service has to be 100% transparent to the user. And all the work I have done, particularly in Cake, we expose as many statistics as possible, and we give total control and totally document how the end user can improve their networking experience. And I feel really sad that things like SNMP, which used to be available on every device you get, is not available for end users that much anymore. So if we could have a renewed push towards openness of the statistics happening in the AQM world as well as the fair queuing world, it would be just great. Not sorry for the passion, but openness on these new technologies. Vint?
Yeah, never apologize for passion on these topics. So Vint, you introduced the topic of quick into the conversation in a couple different ways. One, just how can we continue to measure it with these new metrics? And then also, I think you asked, you just made a comment, there's an argument for quicks multi-channels within one quick connection. I don't know if you had more to say, but before we orient the conversation that way.
It's Vint. I'm not an expert on quick, but others might be. It does have some properties that look pretty attractive, especially if you could avoid opening multiple TCP connections and still get a reasonable queue management effect.
Yeah, I think your initial question that I'll pose to our panel, should we also be looking at instrumenting quick for comparison? Christoph, Matt, Dave?
The answer is we already are. We're experimenting with doing quick NDT-like setting. I won't say we're doing it in NDT, but in an NDT-like application to measure Quick. At the end of the day, Quick and TCP are supposed to be similar, except for some little details of TCP that we got wrong, and the sort of the bulk aggregate behavior are correct. Quick solves what the Vint mentioned one, the multi-threaded, which actually means that it's a better fit to certain kinds of applications. The way I think about this is TCP's got a one-dimensional namespace for data, which is byte offset from the beginning of the object. Quick has got a three-dimensional namespace for data. It's got channels. Within channels, there are blocks, and bytes within blocks. And that richer namespace means that you can do things like interleave images inside of the HTTP connection, and a missing packet for an image doesn't block the rest of the connection. For TCP, I can't deliver the data after the missing packet. For Quick, I don't have that problem. I can do out of order delivery between the channels, and so it's fundamentally better. There's also a technical issue, the retransmit ambiguity problem in TCP, which means that you can't get an RTT measurement from a retransmitted packet because you don't know for sure whether it was the first packet or the retransmit that arrived. Quick solved that problem. What that means is Quick actually functions better under really adverse loss. Quick will run better at 50% loss than you can make TCP run. And that problem isn't going to go away. I mean, that difference is real. But for normal browsing, for single stream, it's specified to have identical behavior. It's also got better security properties because things like sequence number are not exposed. And right now, just by sniffing sequence numbers on TCP connections, you can measure the round trip time and you can measure the loss rate, and Quick hides all that stuff. And so the ISPs are not happy about it, but it's got stronger privacy properties. So there are real differences, and there's reasons that Quick will gradually roll out. Quickest requires differences in the infrastructure, particularly people who are doing NATs need to think about how the caching works differently. And there's a bunch of problems natting Quick that are different than the problems natting TCP. Much could go on. We could have an entire hour conversation about Quick versus TCP in this space, but I think it's off topic for the session. So,
Dave, Christoph, anything to add?
Yeah, I mentioned it briefly in the chat also. I think one additional reason why we should focus also on Quick is because as the internet is moving towards Quick, right, and more traffic for the end users are Quick, we need to measure Quick because the internet behaves very differently compared to TCP versus Quick or UDP, right? Yeah. I mentioned in the chat, 25% of the cellular networks deploy transparent TCP proxies for mostly miseducated reasons, but they do it. They are there, and these proxies have a huge influence on buffer bloat or the perceived buffer bloat for the end user. And so Quick probably doesn't have that problem.
But that's a transient condition until the people who manufacture those proxies catch up, and then they will improve the service by proxying Quick.
Let's go to Dave, and then we'll do a last question from Bob.
All right. So let me jump in on that one because I am not as optimistic about Quick as you all are. Historically, UDP has been the province of low rate or request response protocols. And there's been a lot of networks that were optimized for TCP. And then there's been whole networks optimized to have UDP have strict priority over TCP because it was for DNS and all these other things. So this monster, new greedy protocol jumping in on this space where DNS used to live. And I would like us to worry about that. In particular, just as a totally researchy thing, UDP Lite just works. If we could actually make a little bit progress for there, we get twice the port space and a safe place for applications like this to run to in the long term. But I am concerned about Quick impact on all the other request response protocols we have today, unless we deploy fair queuing and AQM technologies faster than they are.
And Bob, you'll get our last question for today.
Yeah, so I wanted to just say that, for improved transport, Quick, PBRv2 and stuff, that has Broadcom's attention across every chip, from merchant silicon to the switches to the NIC to Wi-Fi. So we're very much interested in getting on that early. And in that respect, is there open source tooling can be released around performance measurements for Quick using whatever metrics are decided, so that, again, we can get the tooling in place so engineers can respond to Quick or how well we're carrying Quick, as you know, and things like that. So if there's an open source tooling effort around Quick, I guess is my question.
Anyone have an answer to that?
There's an interesting twist in Quick that's different than TCP. Since Quick is usually done in user mode and not in the kernel, there's actually no strong forcing function to standardize things that are not exposed either on the wire or to the application. And so the Quick implementations, although there's a open source efficiency issue encouraging them to use the same instrumentation, there's no real forcing function to standardize instrumentation in Quick. And this is actually going to be a problem for us. But there are some packages out there, some Quick implementations that do have instrumentation in them. Like I said, we have somebody experimenting with them. But standardizing Quick instrumentation is actually has the potential of being problematic for us if it doesn't stabilize, if it doesn't gel.
So Robert, you posed a really good question in the chat. Unfortunately, I am just going to guide us to a close. Looking at the time, I know a lot of folks have dropped already. Everyone's contributed to this conversation so much. Thank you for doing so. The benefit of being a panelist is that you get the last word. So we'll go, let's go Dave, and then Christoph, and then Matt for just some closing thoughts and any takeaways that you are taking from today. I forgot the order I just said. Did I say Dave first? Yeah.
Said me first. This is a call in part about research and ongoing further research and metrics that users can understand. The thing is, the research that I'd like to get done is how to get the research into more users' hands faster. The core work that I've been involved in was mostly complete in 2013, and almost anybody today can go upgrade in place in 15 minutes and have a much better network connection. We typically see results 10 to 25 times better using FQCODL or cake-enabled routers, using Apple's responsiveness test, and massively better video conferencing and massively better this. The cost of the software is zero, but there's this comprehension gap that how do we get, let's give you an example, DSL. We could upgrade all of America's DSL routers tomorrow with just e-waste. And the internet would be better for everybody. And I don't know how to get to that point at a policy layer or research layer. I know the RPM metrics were going to help. And that's where I'd like to leave my statement. Thanks.
Thank you. And thank you for being part of the discussion. Christoph?
Thanks. Yeah, I feel like in this call, we have perfectly seen what are the problems around Bufferbloat, in the sense that there are many definitions of Bufferbloat. You can measure it at TCP or at HTTP, different protocols and so on, different ways of expressing it. Should it be RPM? Should it be seconds or milliseconds, right? And this confusion around Bufferbloat is, in my opinion, one of the reasons why it hasn't been fixed, is because nobody has a clear understanding how to measure it. And so if we can get the movement now behind it to actually standardize it and agree on, okay, this is what is Bufferbloat and this is how we're going to measure it. This is the tool or the tools and so on. And then we go and implement those, publish them, make them open source available, make people start using them for customers, for developers, and for engineers. So that it becomes a standard benchmark for network equipment. That would be, in my opinion, a great movement. And I think we have seen some of that happening here, and I hope we can move on with that.
Yeah, part of the reason why I'm so excited about this work is because the responsiveness metric really feels to me like the right answer. It's got the right amount of user understanding. Typical values actually sound like engine values, 3000 RPM, yeah, whatever. And if you're only 50 RPM, you know it. And you know, one of the things that we can't easily test right away, but whether or not the metric actually matches people's intuition about responsiveness. Because one of the things that people run into is, I bought this gigabit network and it's still slow. And the reason is because there's too much uncontrolled buffering. It's not because it's a gigabit, you know, mobile. There are all sorts of things that are going on, and having a user-facing metric that makes sort of intuitive sense to the users, that they can then, and it becomes a definition of the problem, even if it's not a totally authentic definition, but it becomes a definition of the problem. And then technical metrics, engineering metrics, which are parallel, which then let the engineers actually see what they need to do in order to fix the problem. And I see this as being a very, very likely to be successful and actually move the internet forward. And I'm very happy. By the way, there was a comment earlier about we should be reading the chats. The chat has been so busy, I can't even keep up with
I was gonna say, that's
so
hard.
I will be reading it. I will be reading it later because I
Yeah.
couldn't read it while listening to other people talking.
Yeah, multitasking is hard. So thank you, everyone. To that point, I will send out the chat so that we can all reference it, look at all the links and things like that, and also do my best to summarize some of the takeaways from today. As I mentioned, this will also be recorded, so there will be thousands of ways to revisit our time here. Thank you so much for coming. If you, like I said, if you RSVP'd, you'll be invited to more. And if you have feedback for the call, you know, we've been doing these for a year. And they're different every time. So we're open to feedback and how we can make them the most useful for the community. Thank you, everyone, and have a good day.
Thank you. Bye.
Thanks,
Bye,
and bye.
everybody. Thanks for coming.
Thank you.
I figure I'll stay.